There's two main things we can do after we take a sample. We can either find the mean or we can find the proportion. So for example, say we take a sample of 30 people. An example of finding the mean or average would be finding the average age. An example of finding a proportion would be finding the percent that likes Netflix. The mean situation we talked about in the last lecture. So the new situation in this lecture is the proportion situation. Now the central limit theorems, so these are the central limit theorems tell you when you're allowed to use the normal distribution. In other words, when can we draw this picture that we've been drawing for every single situation? Now for the mean situation, we talked about this last time. For the mean situation, if your sample size is large enough, then yes, you can use the normal distribution. What's large enough? Large enough means bigger than 30. So if your sample size is bigger than 30, then yes, you can use the normal distribution regardless of what the original population looks like. Now, what I didn't talk about last time was, what if your sample size is not large? So what if your sample size is less than or equal to 30? So if your sample size is small, then you need to know that the population, that original population is normally distributed before you're allowed to use the normal distribution, okay? Which is why in the very first lecture, when we introduced the normal distribution, I was careful to include the words normally distributed in every single situation. That's because in that lecture, we were only picking a sample size of 1. And then even more, the central limit theorem tells you what mean you should use and what standard deviation you should use when you use the normal distribution. So we saw this last time. For the mean situation, the mean you should use is the original population mean. The standard deviation you should use is the original standard deviation of the population divided by square root of n, which is the sample size. Now, for the proportion situation, when are we allowed to use the normal distribution? Same idea. If your sample size is big enough, then yes, you can use the normal distribution. So what does big enough mean in the proportion situation? In the proportion situation, it doesn't have to do with 30, right? It has to do with these two criteria. So if n times p is greater than 10 and n times 1 minus p is greater than 10, then yes, you can use the normal distribution. N here is the sample size, p is the population proportion. So if those two things are met, then yes, your sample size is big enough, and yes, you can use the normal distribution. And then in the box here, this is telling you what mean you should use and what standard deviation you should use when you use the normal distribution. So the mean you should use is the population proportion. The standard deviation you should use is this big square root formula. The second page is just a formula sheet. So what I did was I recopied the two boxes from that front page here. So the first box is for the mean situation, what mean you should use and what standard deviation you should use. For the proportion situation, what mean should you use and what standard deviation you should use. And then at the bottom, this is the same diagrams that we've been using for the last two lectures that tell you your workflow for an X to area type question and for an area to X type question. And remember that anytime you see those three P words, probability, percent, proportion, it's referring to an area. So if a question asks, find the probability, find the percent, find the proportion, it's asking you to find the area. Let's try some examples. Example 1. The National Coffee Association reported that 63% of US adults drink coffee daily. A random sample of 250 US adults is selected. Find the probability that more than 67% of the sampled adults drink coffee daily. So the first thing I'm going to do is I'm going to draw the normal distribution picture just like in the previous 2 lectures. But before I put the mean in the middle, I now have to decide whether this is a mean situation or a proportion situation, right? Because these boxes will tell me what I need to use for the mean. So as a hint, when you read the question, if you see the words mean and standard deviation, it's going to be a mean situation. If you don't see the word mean or standard deviation anywhere in the question, it's going to be proportion. So when we look at this question again, we don't see the word mean or standard deviation anywhere in the question. So this is going to be a proportion question. And because it's a proportion question, the proportion box will tell us what we need to use for the mean and what we need to use for the standard deviation. So let's write that down. So the mean we need to use is going to be P. So P here stands for the population proportion. So it's the proportion, usually it's going to be a percent, of the population that has a certain characteristic. So in our case here, it's the 63%. So 63% is the percent, and the special characteristic is that these 63% drink coffee daily. And as usual, anytime we're working with percents, we always convert it to decimals first. 63% as a decimal would be 0.63. That's our mean. So let's put the mean in the middle, 0.63. And then let me label the x-axis as usual. For proportion questions, the x-axis is always going to be proportions. And then let me write down the standard deviation. Okay, the standard deviation is going to be this big square root formula. So big square root. Okay, and it says P, 1 minus P over N. P is this 0.63. So 0.63, 1 minus 0.63 over N. N is a sample size. In other words, how many people are we picking here? 250 US adults. So 250. Okay, so let's enter this into our calculator. So square root, okay, inside the square root, fraction. Okay, so make sure that fraction is inside the square root. So I think the easiest way to do that is to click on the square root and then click on the fraction button, this A over B, to get that fraction inside the square root. Okay, so inside the square root, on top, it's going to be 0.63, parentheses 1 minus 0.63, on the bottom, 250. Okay, round to 3 decimal places, this is 0.031. Okay, so the mean we're going to use for this entire problem will be 0.63. The standard deviation will be 0.031. Now, from here is similar or the same as what we did in previous 2 lectures. I need to decide what type of question it is. Is it an x to area or an area to x? And then I also need to decide whether it is shaded left, shaded right, or shaded between. So first of all, x to area or area to x. So read the very last sentence, the question. It says, find the probability. Probability, remember I said, if you see the words probability, percent, proportion, that's an area. So this is find the area. Find the area. So I want to end with an area when I finish the question. So which one of these ends with an area? X to area. Okay, so this is going to be for sure an X to area question. Okay, so if it says find a probability, find a percent, find a proportion, those are all going to be X to area. So then the next question is, shaded left, right, or shaded between. So the rest of the question here, find a probability that more than 67%, okay, 67%, that's a proportion that goes on the x-axis. So that's our x. And then I see the words more than. Okay, more than would be to the right. So more than, greater than, those all mean to the right. So this is going to be shaded right. All right, so we said this 67% is an x, so that goes on the x-axis. Once again, convert it to a decimal. So that's 0.67. That would go right here. And then we said shaded to the right. Okay, so from here, the rest of the question is just like any x to area shaded right question. So if you need to, go back to the very first lecture that we did on normal distribution and look for an x to area shaded right question. All right, so x to area, first thing I need to do is this z formula to find a z-score. So z, so x minus the mean, our x we said was this 0.67, minus the mean is the 0.63, what we put in the middle. Standard deviation, we found a standard deviation, 0.031. Okay, so on our calculator, up top, 0.67 minus 0.63, on the bottom, 0.031. Rounded to 3 decimal places, this is 1.290. Okay, so we just did the z-score formula. Next step will be to go from z to area by doing a p-norm. So we're going to p-norm that z. So p-norm, the z here is 1.290. Okay, in R, p-norm 1.290. Round to 3 decimal places, this is 0.901. Now remember, p-norm, the way p-norm works is it takes a z and it spits out the left area. So this is a left area. Okay, which means if you are looking for a left area, you're done. If you're not looking for a left area, you have to do something else. Are we looking for a left area? No, we're looking for area to the right, okay? So we need to do something to this left area to get the area to the right. So this 0.901 refers to the area on the left, which is this white part. We want the other part, the one on the right. So to get the other part, do a 1 minus. Okay, 1 minus 0.901. 0.099. Example 2. On a certain television channel, 18% of commercials are local advertisers. If a sample of 120 commercials are selected, there's a 75% probability that the proportion of commercials that are local advertisers is greater than what value? The first thing I'm going to do is I'm going to draw the normal distribution picture. But before I put the mean in the middle, I need to decide whether this is a mean question or a proportion question. Okay, and the way you decide is when you read this question, if you see the words mean and standard deviation, it's going to be a mean question. If you don't see the words mean or standard deviation anywhere in the question, it's a proportion question. So when we look at this question again, do you see the words mean or standard deviation anywhere in the question? You don't. So this is going to be a proportion question. And because it's a proportion question, the proportion box is going to tell us what our mean and what our standard deviation should be. So the mean is going to be P. Okay, the mean is going to be the P, which is the population proportion. And usually it's going to be a percent. So on a certain television channel, 18% of commercials are local advertisers. That's our repeat, 18%. As a decimal, 0.18. Our standard deviation, that's going to be this big square root formula. So big square root on top, it's going to be p, which is 0.18. 1 minus 0.18 over n is the sample size. Usually it's how many people are we picking, but in this case we're picking commercials. So how many commercials are we picking? Sample of 120 commercials. So 120. Okay, so on our calculator. So the best way to do this is click on the square root button first, and then click on the fraction button, which is the a over b. So that forces the fraction inside of the square root, and then inside the square root on top, 0.18, 1 minus 0.18 over 120. Make sure that the entire fraction is inside the square root. And I get 0.035. Okay, so for the rest of this question, the mean we're going to use is 0.18, the standard deviation 0.035. So the mean, 0.18, that goes in the middle. And then let me label the x-axis. For proportion questions, the x-axis will be proportion. Now, I need to decide whether this is an x to area or an area to x. So let's read the question again, the very last sentence. If a sample of 120 commercials is selected, there is a 75% probability. Okay, so in the question, I'm giving you 75% probability. What is that? Is that an x or is that an area? Probability, right? That's one of those P words that I said you should think area. So that 75% is an area. So I'm giving you an area to start. Which one starts with an area? Area to x. This is going to be an area to x question. And then to finish off the type of question, is this going to be shaded left, shaded right, or shaded between? 75% probability that the proportion of commercials that are local advertisers is greater than what value? Greater than. Greater than. That tells me that this is going to be shaded to the right. And let me draw the rest of the picture. Okay, so I need to put this 75% on my picture. That's an area, so that doesn't go on the x-axis. That's going to go up top here. And we said it was shaded to the right. Okay, so I want 75% to the right, so that's actually going to go over here. It's not that important that you put, this is going to be an x. 75% is an area. As a decimal, that's 0.75. And we said areas go up here. And what I meant to say was that it's not that important that you have the x in the right, on the right side, right? I put it on the left side here. You can also put it over here. Just make sure that you are shading to the right. That's the important part. Okay, so this is going to be like any x area to x shaded right question. So we need to go back to the very first lecture where we talked about normal distributions and look for an area to x shaded right. The steps will be the same. Area to x, first thing I need to do is do a Q norm, left area. So we're going to start off by doing Q norm. Left area. This 0.75 is not a left area, right? This 0.75 is this shaded part to the right, right? I need to find the left area to plug into Q norm. The left area will be this white part. So I know 0.75 is to the right. To find the other side, do a 1 minus. So we're going to do 1 minus 0.75. 0.25. Okay, that's this white part to the left, and that's what I need to plug into Q norm. In R, Q norm 0.25. And the way Q norm works is it takes an area and it spits out a Z. So that's a Z. So our Z is negative 0.674. Okay, remember to round each intermediate step to 3 decimal places. Okay, we just did area to Z using Q norm. Last step, Z to X using the X formula. So X formula, X equals mu, that's the mean. Our mean we said was 0.18 plus Z times the standard deviation. Our Z was this negative 0.674 times our standard deviation 0.035. Okay, plug this to the calculator. 0.18 plus negative 0.674 times 0.035. 0.156. Example 3. The lifetime of light bulbs has a mean of 1,500 hours and a standard deviation of 100 hours. If 50 randomly selected light bulbs are tested, what is the probability that the mean lifetime is less than 1,520 hours? First thing I'm going to do is I'm going to draw the normal distribution picture. Before I put the mean in the middle, I have to decide whether this is a mean question or whether it's a proportion question. So when you read the question, if you see the words mean and standard deviation, it's going to be a mean question. If you don't see the words mean and standard deviation, it's going to be a proportion question. So looking at this question again, do we see the words mean and standard deviation? Yes. So mean, standard deviation. So this is going to be a mean question. Okay, because it's a mean question, I'm going to be using the mean box to write down my mean and standard deviation. The mean is going to be the original mean of the population. The mean we're going to use is the original mean of the population, which is going to be the original mean in the question. Mean 1,500. The standard deviation is going to be the original standard deviation of the population divided by square root of n. Okay, the original standard deviation is 100 divided by square root of n. N is the sample size, so usually it's the number of people that we're selecting. In this case, we're talking about light bulbs, so the number of light bulbs that we are selecting. 50 randomly selected light bulbs. It's going to be 50. So on a calculator, 100 over square root of 50. And then round to 3 decimal places, 14.142. Okay, so for the rest of the question, the mean we're going to use is 1,500, the standard deviation 14.142. So I'll put the mean in the middle, 1,500, and let me label what the x-axis represents. So for mean questions, you do have to read the question and see what the x-axis represents. So 1,500, what is this 1,500? Hours. So you can say hours, or you can say lifetime of light bulbs. So anytime I see hours or lifetime of light bulbs, I know that's going to be an x. The next thing I need to decide is this an x to area or an area to x question? So let's read the last sentence. If 50 randomly selected light bulbs are tested, what is the probability? Okay, probability, one of those P words that I said you should recognize as area. So what is the area? So I want area as my final answer. Which one of these ends with an area? X area. So this is for sure going to be an X area. And then another way to decide that is read the rest of the question here. What is the probability that the mean lifetime is less than 1,520? 1,520 is in hours. Hours we said was the x-axis. So that 1,520 is an x. So I'm giving you an x to start, right? X to area starts off with an x. Now I need to decide shaded left, shaded right, shaded between. What is the probability that the mean lifetime is less than? Less than tells me that this is going to be shaded to the left. So this is shaded left. And let me draw the rest of the picture with the shaded left. 1,520, we said that that was an x. That goes over here on the right side. And then we said we're shading left. All right, so now we're set up. This is an x to area shaded left. So we need to go back and look for an example of an x to area shaded left. The steps will be the same. For an x to area, the first thing I need to do is the z-score formula. So z equals, up top, x. Our x is this 1,520 minus the mean. Our mean was 1,500 over the standard deviation, which is this 14.142. Okay, make sure you're using the standard deviation that you calculated and not the original standard deviation of the population. So in our calculator, up top, 1,520 minus 1,500 over 14.142. Rounded to 3 decimal places, this is 1.414. Okay, so we just did the z-score formula. The next step will be z to area by doing a p-norm. So we're going to do p-norm. The z, our z was 1.414. So in our p-norm, 1.414, 0.921. So anytime you're doing a p-norm, you feed it a z, it outputs a left area. So that 0.921 is a left area. Okay, if you're looking for a left area, you're done. Are we looking for a left area? Yes, so we are looking for a left area. This is a left area, so we're done. So our final answer is 0.921. The lifetime of a certain automobile tire is normally distributed with a mean of 40,000 miles and standard deviation 5,000 miles. Between what two lifetimes do 80% of tire lifetimes fall between? So first thing I'll do is I'll draw the normal distribution picture. Before I put the mean in the middle, I need to decide whether this is a mean question or a proportion question. So reading this question, if you see the words mean and standard deviation, it's a mean question. If you don't see those words, it's a proportion question. So do we see the words mean and standard deviation? Mean, standard deviation. This is a mean question. Okay, and then let's use the mean box to write down the mean and standard deviation. Our mean is going to be the original mean of the population. So the mean is going to be the original mean of the population. So the original mean in question. Mean 40. Standard deviation is going to be the original standard deviation of the population divided by square root of n. So original standard deviation, 5, over square root of n. So n here is sample size. How many people are we selecting? In this case, we're talking about tires. How many tires are we selecting? And remember, if it doesn't say, we're going to assume the number of tires is 1. So it doesn't say, right? I see a 40, that's the mean, 5, standard deviation, 80%, that's not a sample size. So it doesn't say a sample size, so we're going to assume it's 1. Okay, you can do that on your calculator, but you'll get 1. I mean, no, sorry, you'll get 5. Okay, so mean we're going to use is 40, standard deviation we're going to use is 5. Then we put the mean in the middle. And then because it's the mean question, I do want to label this x-axis. So what is this 40? It's 1,000 miles. I'll just write miles. So anytime I see miles or tire lifetime, that's referring to an x. Next thing I need to decide is this an x to area or an area to x question? So looking at the last sentence, between what two lifetimes do 80% of tire lifetimes fall between? So it says what two lifetimes? And I also see this 80%. Okay, percents, one of those P words, that's an area. So one way to think about this is I'm giving you an area to start. Which one starts with an area? It would have to be area to x. Another way to think about it is the question is asking what two lifetimes, right? Lifetimes are miles on the x-axis. So I want to end with an x at the end when I finish the question. So area to x ends with an x. Okay, shaded left, shaded right, shaded between. Obviously between. Okay, so this is going to be shaded between. So I need to put this 80% on my picture. That 80% is an area, so it doesn't go on the x-axis. It's going to go up top here. We said it's going to be between 80% as a decimal is 0.80. And then we're looking for the two tire lifetimes, so the two x's here, that have an area of 0.80 between. So now we're set up. So this, from here, it should be the same steps as any area to x shaded between type question. So we need to go back to the original normal distribution lecture and look for an example of an area to x shaded between. Area to x, first thing I need to do is q-norm the left area. So we're going to q-norm the left area. Now, 0.80 is not a left area. That's the area between. I want this white one, white area here to the left. So the first thing I'm going to do is I'm going to do 1 minus 0.80. That's going to give me the unshaded part, which is the left and the right together. Because I just want the left, divide by 2. So we're going to do 1 minus and then divide by 2. So 1 minus 0.80 is 0.2. Okay, so when you do 1 minus, that will give you the unshaded part, which is the left and right together. Because I only want the left, divided by 2. So 0.2 divided by 2. 0.2 divided by 2, 0.1. Okay, 0.1 is the left white part, which is what I want to plug into R. So we're going to q-norm 0.1. Okay, and the way q-norm works is it takes an area and it outputs a z. So that's going to be a z. Because at the end of the day, I want two x's, I need two z's. So this z, the negative 1.282. Okay, and that's going to give me the left x later on. For the right x, that's just going to be the positive version. So positive 1.282. All right, so we just did area to z by doing Q norm. Last step, z to x, using the x formula. So we'll do the x formula for both of these z's. So x equals mu, the mean, which is the 40, plus z times the standard deviation. Our z here is negative 1.282 times the standard deviation, 5. Okay, so let's write this out, or use a calculator. 40 plus negative 1.282 times 5. 33.59. Okay, that's one of the x's. Same thing for the other z. X formula, x equals mu, which is the mean, 40, plus z times the standard deviation. Z here is the positive 1.282 times the standard deviation, which is 5. Okay, into the calculator. 40 plus, okay, positive 1.282 times 5. 46.41. All right, that's it for today. Have a great day. See you next time.